Alright kids, so here we are, the last, number 4 of 4, in the final exam review. Alright, we're gonna go 31 to, I think it's only 39, and then we are done for the year, so exciting. Anyway, number 31, graphing quadratics. So we're asked to graph this on the grid below. So there's some things that we need to know. The first thing we need to know is to come up with the vertex. So the vertex, the recipe is, first you have to find the x vertex, so that's minus b over 2a. So minus b, that's going to be negative of negative 3, which is positive 3, divided by 2a, so that's just going to be 1.5 is the x vertex. So 1 minus b over 2a, that's right. Okay, so where's the y vertex? Well, to find out, you have to plug in 1.5 in here, and 1.5 in here. That's just this equation over here. In place of x equal 1.5, in place of x equal 1.5. So 1.5 squared minus 3 times 1.5 plus 2. And I think I plug that into my calculator and get negative 0.25. So it's going to be 1.5 to the right and down 1/4 of the way. Now that really is terrible to graph. But I know that I have this axis of symmetry that goes straight down the middle of the vertex. And then from here I can find the y-intercept. Now to find the y-intercept, I let the x equal to 0. So if x is 0 and x is 0, that's gone. Now that's left is a 2. So here is 1 point. So you can use the symmetry of the parabola. So the other point must be here. So there's your vertex. So normally we go out 1, out 1, up 1, because the leading coefficients are 1. So out 1, up 1, out 1, up 1, out 2, up 4. I'm just going to use the symmetry of these, the y-intercept to soften. But that feels about right. Out 1, up 1 right here, out 1, up 1, and then you go out 2, that's 1, 2. That's going to be up 1, 2, 3, 4. Okay, totally legit. Okay, there's your graph. So, the vertex. The vertex was negative 0.2. There you go. So you're going to have to remember this little recipe. Minus b over 2a. That's how we find your x's symmetry, and that's also how we find the x vertex. And once you find that, you just plug into x here, here, and there's the equation here, here, and then you work it out. Alright, let's move on. Solve by factoring. Oh, this is easy. So the thing is that once you factor, you can use this thing called the zero product property. The zero product property, which states that anything times 0 is 0. So this factors into 5 and 7, negative 7 plus 5. So the zero product property states that anything times 0 would have to be 0. So x plus 5 can be 0. Or x minus 7 is equal to 0. You can solve for x minus 5 to both sides, and x is equal to 5. You can add 7 to both sides, and x is equal to 7. So two values of x that would make it true. But the thing is, you have to first factor and then use the idea of the zero product property. Okay, so on this side, the factors of this is going to be x minus 5 times x minus 6. 5 times 6 is 30, plus the other negative 11, total reject. And once you use the zero product property, you can see how x is going to be positive 5 and positive 6. Just set equal to 0 and you solve for this. Okay, let's move on. Where are we now? 33. 33. Alright, let's do this. Solving area using quadratics. So the length of a rectangle is 5 inches more than the width. The area is 126 square inches. What's the width? What's the length? So first draw your picture. So here's your width. Usually it's a short side. It doesn't have to be, but it is in this case. So the length is 5 more. So W times 5? No. W plus 5. Right there. 5 more. And then the area, just the width times length is equal to the area. So that means we have W times W plus 5. Now that's equal to 126. Then we can distribute the W, and we have W squared plus 5W is equal to 126. We can minus 126 from both sides, and we have W squared plus 5W minus 126, and that's equal to 0. And then, oh my goodness, we can solve for this by factoring if we know how to factor. Let me think about this. We can factor, it means I have to look for factors 126, and it has to add up to like 5. So what are the factors? I know what are the factors. They have to multiply to give me negative 126. So does it sound like I'm stalling? I might be stalling. I am not stalling. I know that the factors are going to be 14 and 9. Positive 14 and negative 9. 14 times negative 9 is negative 126. And if we add it up, we get 5. Totally legit. And then you can solve for W by using the zero product property. W is equal to negative 14, or W is equal to positive 9. Now, really, W could be equal to negative 14, or W could be equal to positive 9. I think this answer here is extraneous, because really, it's impossible to have a negative distance. So W has to be equal to 9. So that is going to be 9 feet. So the width, that's going to be 9. Now, I don't think they asked what the length would be, but to find out the length, you know that it's going to be W plus 5. So that's going to be 9 plus 5, or 14 feet. But this is the answer, because they're asking for the width. Alright, what's next? Completing the square. Oh, complete the square. There are 2 necessary conditions to complete the square. The first one is that A has to be equal to a 1. And then the second thing is that the C has to be half of B squared. You take the B, you divide by 2, and then you square the outcome. So they're asking what should be added to both sides of the equation to complete the square. So A is a 1, here is your B, and your C needs to be negative 18 divided by 2 and then squared, which is negative 9 squared, which is 81. So we should be adding 81 to both sides. Now, they're not asking us to solve for this, but we can, because you can see that on the right side, we can add 27 to 81, and we get like 108. And then on this, it factors into x minus 9 finally squared. And then x minus 9 would be equal to plus or minus square root of 108. Because we can take the square root of both sides and the square undo the square root, and which is left with x minus 9. And then this side, whatever 108 is, to take the square root of that, it could be plus, it could be minus. And then to solve for x, we just add 9 to both sides. So it's going to be 9 plus or minus square root of 108. And there's our answer. We can do more of it, but it's fine. They're just asking for what must be added. So this one, it's going to be 20 divided by 2 and then square. That's going to be 10 squared or 100. Not asking us to solve for it. We could, anyway. We didn't. They're just asking for this number. Alright, so memorize the quadratic formula. Okay, nothing for me to do here. You just have to memorize that. You can think about a song, you can sing it to Pop Goes the Weasel, or you can tell a story about a little boy, how he's going to some party, and it's over at 2 a.m. You know the story. Alright, so moving on to 36. So what is 36 here? To solve using the quadratic formula. Okay, so here are the procedures. First you set the equation equal to 0. Then you locate your ABC, what are those numbers? And then you find your discriminant. And then you put the whole thing into the equation. The equation is just 0. Where's the equation? There's the equation. Right there. Alright, let's do this. So that's not equal to 0. So to get equal to 0, you minus 1 to both sides. You end up with 3x squared minus 9x plus 3 is equal to 0. Now, we can work with a is 3 and b is negative 9 and c is 3, but I notice that they all have a common factor of 3, so we can divide everything by 3, right? Multiply 3 by 1/3, and I end up with x squared minus 3x plus 1 is equal to 0. So now the ABC is much easier to work with. You can see that a is a 1, and b is a negative 3, and c is equal to 1. Alright, so first I'm going to just work out the discriminant, because it's just easier. So b squared is negative 3 squared. Negative 3 times negative 3 is positive 9, minus 4 times a, which is 1, times c, which is 1. So it's going to be 9 minus 4, which is equal to 5. And that's your discriminant. Alright, so now x is equal to minus b. Minus b, that's positive 3, plus or minus square root of 5, and that's divided by 2a, which is just 2. So there's your answer. So these are two different outcomes. The first answer is x is equal to 3 plus square root of 5 divided by 2. And the other answer is x equal to minus it's equal to 3 minus square root of 5 divided by 2. I think it's easier to write the answer like this, you know, plus and the minus. Alright, so for this one, I think I'm going to add x squared to both sides and then minus 4 to both sides. Get the 0 equal to here, so it's going to be x squared plus 11x plus 4. And that's equal to 0. So a is equal to 1, and b is equal to 11, and c is equal to 4. And then we're going to look for the b squared minus 4ac, which is 11 squared, 121 minus 4 times 1 times 4, which is 121 minus 16. And 121 minus 16, is that a nice number? That's like 121 minus 16, and that's equal to 105. Alright, so now we have x is equal to minus 11 plus or minus square root of 105, and that's divided by 2 times 1. So there it is. And we're done. We're almost done. Let's turn the page to see if we're done. Oh my goodness, the last one. Alright, let's do this. So this equation, you may notice that it starts out at 1. And then at 1, so that when x is 0, y is 1. That's the beginning. When x is 1, y is 2. And then when x is 2, y is like 4. So you can see when x is 3, y is like 8. So you can see it's a doubling function, isn't it? It goes from 1 to 2 to 4 to 8. So that's your function right there. Y is equal to 1 times 2 to the x. That's the beginning value. That's the growth function, doubling. So let's say that we have a translation of g of x. That's the parent function. There's another function. So we have a minus 3 here, we have a plus 1 here. So everything is the same, except that it moves 3 units. It's minus, which really makes you think left. but in fact it's right because, oh my goodness, the right left stuff is backwards. This stuff here tells you when it's on the outside, it's up, down, and it's normal, so it's 1 unit up. So you see here's the original function. It starts at 1, it goes to 2, it goes to 4, it goes to 8, it goes to 16. It goes this way, it goes 4, 2, 1, 1 half, 1 fourth, 1 eighth. It goes almost down to 0, which is this line. But this gets translated 3 to the right and 1 up. So now, there's your new horizontal asymptote. Okay? And then, see this point here? We can move this point 3 to the right. 1, 2, 3, and then 1 unit up. So now, this function is just like this. Right? So here's the original function y, and here's the function g of x. Yeah, it just moves 3 units to the right and 1 unit up. It tells you right over here. Alright. Then 2 more problems and we're done. Good. So a student left her Tupperware with Ms. Gardner's classroom. The Tupperware originally has 200 bacteria. Number increased 24% per day. What's the bacteria after 6 days? Write the formula. How many bacteria after 6 days? All right. So the function is y is equal to a times b to the x. A is the initial amount. B is your growth factor. That's 1 plus r. Now in this case, r is 24. So that's your rate of growth over there. And then x is time in terms of days or hours or whatever. In this case, it's days. And then y is how much bacteria after x time. So it's going to be y is equal to a, the initial amount. The initial amount is 200 of those little bacteria. And then the b, that's 1 plus the r, and the r is 24%. So it's 1 plus 0.24. And it's to the x power. So there's your function. But I think it would be pretty if you write it as like f of x is equal to 200, and then it's 1.24, and then it's 2. That's a pretty function. So let's replace x with 6. So f of 6 means how many bacteria on day 6. That's 200 times 1.24 into the 6 power. So your calculator is smart, it knows order of operation, so you can just type it in the way it's written, 1.24. Oh, and so the calculator, in case you don't know, it's 200, and then you go multiply, and you go 1.24, and then you do that exponent, that's the half, and then you put number 6, and then push enter. Alright, so where's the half? Oh, there's the half. And I'm going to put 6. So that's 200, 1.24 to the 6 power. And that comes out to be 727.0430.55. All this, of course, is ridiculous. Because you're not going to count part of bacteria. So that's just going to be 627 different bacteria. Right? Finally, the last problem. So, interpreting a box and whisker plot. So here's the little box and there's the whisker. And look, this is going to be the lowest score, the minimum. This up here, that's going to be the maximum score. The median, that's right in there, that's what we call the median. That's the number that's exactly in the middle. So 50% from here to here, that's low. 50% here, that's high. And then this over here, that's your Q1. That's the median of the lower half. And then this over here is your Q3. Now that's the median of the upper half. So it's 25% here, 25% here, 25% here, 25% here. So sometimes the box is longer than the others, sometimes the whisker is longer than the others. It just tells you that's the maximum score and that's the lowest score of the 25%. So sometimes it has a broader range, sometimes it has a smaller range. But that's essentially the box and whisker. The whole thing is 100%. So min, max, median, Q1, Q3. Median is in the middle of the whole thing. Q1 is the median of the lower half. Q3 is the median of the upper half. So here you can see is your box and whisker. You can see there's a bigger range on the upper 25% and a smaller range in the lower 25%. Not always like this, just so happens this is the one. So this is number of keys. So the plot above represents the number of keys on the key chains of teachers at Wilson. What percentage of teachers have 3 to 8 keys? So here's 3, and here is 8. 8 looks like the maximum, 3 looks like it's the median. So 25% here, 25% here, 25% here, 25% here. So between 3 to 8 keys, that's going to be 50%. And then what percentage of 1 to 2 keys? So here's 1, that's the minimum. Here's 2, so this one is the lower 25%. That means 25% of teachers at Wilson only carry 1 to 2 keys. So what does that say? Percentage 1 to 2 keys, that's 25%. These are the privileged people. They don't carry a lot of keys. And, oh my goodness, I think I am done for the year. So there is the last of your final exam. I hope you study this. I hope you get a lot of good things from it. And I hope you have a good semester. Alright, bye kids.